Good afternoon, students. Are you able to see the PCV? Are you able to hear my voice? Okay. Any one of you, please chat. Are you able to see the PCV slash slide number 19? Are you able to hear my voice? I hope that you all are seeing the video, and we will continue that. And again, very good afternoon to all of you. In our previous class, we have started that application of determinants and discussed a few problems. Okay, so today also we continue that. So the next problem is solve 2 by x plus 3 by y plus 10 by z equal to 4, and this is 4 by x minus 6 by y plus 5 by z equal to 1, and 6 by x plus 9 by y minus 20 by z equal to 2. Okay, 2 by x plus 3 by y plus 10 by z is equal to 4. And 4 by x minus 6 by y plus 5 by z is equal to 1. 6 by x plus 9 by y minus 20 by z is equal to 2. Okay, so now look at that. We have to take it as, first of all, write the coefficient matrix. What are the coefficients of 1 by x? So in many of the equations, here you will x, y, z will given. Okay, but here 1 by x, 1 by y, 1 by z is given. You have to take it as your 1 by x is the variable. So therefore, the coefficient of 1 by x is 2. The coefficient of 1 by x is 4. The coefficient of 1 by x is 6. Similarly, coefficient of 1 by y 3 minus 6, 9. Okay, and this is 10, 5 minus 20 into, so the variables unknowns. So that is, take it as 1 by x, 1 by y, 1 by z, the unknowns. Okay, that's equal to this right hand side value is 4, 1, 2. Okay, now take it as, this is your coefficient matrix is, take it as capital A, and this unknown matrix is, take it as capital X. Okay, and this matrix is, take it as B, capital B, right? And pre-multiplying both the sides by A inverse, here also multiply by A inverse, here also multiply by A inverse, and simplify, you will get it x is equal to A inverse into B, because we need x. X is the unknown matrix, unknown values matrix. Okay, we are going to find out that x only, right? So now, first of all, find your A inverse. What is A inverse formula? The A inverse formula is 1 by determinant of A adjoint of A. Find determinant of A. This is your A. Find the determinant of A. So therefore, A is equal to 2 into, this is plus minus plus. Okay, this is 2 into, this is 120 minus 9 5s are 45. Okay, and minus 3 into, this is minus 3 into, this is 4 into minus 20, and this is 6 into 5 plus 30, but we have another minus 30. Okay, and plus 10 into, this is 4 9s are 36. Here minus of minus 36. This is, I am just finding the determinant value. We know that we have discussed many problems of finding determinants. Okay, so therefore here 120 minus 45. So that is 75. 120 minus 45 is 75. 2 into 75, 150. This is minus 110. Okay, minus into minus plus. Okay, 310 into 3, 330. right? This is minus into minus, plus 36 plus 36, 72, 72 into 10, that is 720. Okay, so therefore 150 plus 330, that is 480, 480 plus 720, so that is 1200. And this is not equal to 0. If determinant A is not equal to 0, then A is non-singular. Non-singular means A inverse exists. If A inverse exists means we will get a unique solution. Please note that we have discussed uh, 3 cases. Okay, look at that. Consider the system of equation. Write the system in matrix form. If A is non-singular, we will get it x is equal to A inverse B. If x is equal to A inverse B means we will get the unique solution. Solution of x is unique. Okay, if A is singular, singular means determinant A equal to 0. If it is singular, then we have 2 cases. One is adjoint of A into B not equal to 0, then the system is inconsistent. If the adjoint of A into B equal to 0, then the system may be either consistent with the infinite number of solution or inconsistent, no solution. Okay, so therefore if A is non-singular, we will get a unique solution. A is non-singular means we will get a unique solution. Then go for the adjoint of A. Okay, so the adjoint of A we have discussed in many problems. Therefore, I'm going to write that adjoint of A directly. So that is a homework for you. You please note that. You try to find out that adjoint of A properly. My adjoint of A, I'm writing directly the adjoint of A, values of adjoint of A, that is the cofactors of the elements. Okay, so the first element cofactor is 75, and here 110, here it is 72, this is 150, this is minus 100, this is 0, this is 75, this is 30, this is minus 24. I'm just writing the cofactors. Okay, and take a transpose. That is my adjoint of A. This is a homework for you. You please note it. Okay, so because we have discussed many problems to find the adjoint of A, that means write the minor first and multiply by plus. Write the minor and multiply by minus. Write the minor, multiply by plus. So you will get that adjoint of A with the transpose. Right now, what is my A inverse? My A, take a transpose here. Transpose of this. What is the transpose? Write row into column. 75, 110, 72. This is 150 minus 100, 0. And this is 75, 30 minus 24. Okay, now come to that A inverse. What is my A inverse? My A inverse is equal to 1 by determinant of A, adjoint of A. Okay, what is determinant of A? 1200. What is my adjoint of A? This is the adjoint of A. 75, 150, 75. Okay, 110 minus 100, 30 and 72, 0 minus 24. Okay, right. Now come to that, your x is equal to A inverse of B. A inverse exists. Exist means we'll get a unique solution. This is 1200. What is your A inverse? Your A inverse is 1200 of 75, 150, 75, and 110 minus 100, 30, and 72, 0 minus 24. Okay, that B matrix. We have to multiply A inverse into B. What is your B? 4, 1, 2. So that is 4, 1, 2. Okay, so multiply that. This is 1200 into, how to multiply that? Row by column. This is 4 into 75. This is 1 into 150. This is 75 into 2. 2 into 75, 4 into 75. So totally it is 450, 450 plus 150, that is 600. You just simplify that, you'll get the answer. Okay, this is 4 into 110, 440. This is minus 100 into 1, minus 100, 440 minus 100, plus 340, 340 plus 60. So therefore it is 400. You just simplify, I'm writing the answer. So this is 72 into 4. Okay, so therefore 288. minus 48. 288 minus 48, that is 240. Okay, now multiply this for 1000, 1 by 1200 to inside. So therefore, this is here 600 by 1200. What is the answer? 1 by 2. Here 400 by 1200. 400 by 1200. What is the answer? 1 by 3. This is 240 divided by 1200. Okay, cancel it. We will get 1 by 5. What about your x? Your x is nothing but 1 by x, 1 by y, 1 by z. Your x is 1 by x, 1 by y, 1 by z. Now look at that. Your 1 by x is equal to 1 by 2. Two matrices are equal, mean the corresponding elements are equal. 1 by x is equal to 1 by 2. Then what is your x? X is equal to 2. You find x, y, z. Solve means you have to find out x, y, z. Your 1 by x is 1 by 2. 1 by y is 1 by 1 by y is equal to 1 by 3. 1 by z is equal to 1 by 4. Therefore, your x is equal to 2, y is equal to 3, z is equal to 5. So therefore, this is the answer. X is equal to 2, y is equal to 3, z is equal to 5 is the answer. Please take that. So therefore, your 1 by y is equal to 1 by 3, which implies y is equal to 3. 1 by z is equal to 1 by 5, which is equal to z is equal to 5. So therefore, your answer is x is equal to 2, y is equal to 3, z is equal to 5. How to verify these answers? You substitute these values in your given equation. You substitute that x is equal to 2, y is equal to 3, z is equal to 5 in this equation. If your solution satisfies all the three equations, then only that is the correct answer. If your solution, this x is equal to 2, y is equal to 3, z is equal to 5, satisfying all the three equations, then only it is a correct answer. Okay. And look at that another question. Use product one minus 1, 2, 0, 2 minus 3, 3 minus 2, 4, minus 2, 0, 1, 9, 2 minus 3, 6, 1 minus 2. To solve the system of equations, to solve the system of equations, x minus y plus 2z equal to 1. 2y minus 3z equal to 1. And 3x minus 2y plus 4z equal to 2. So please try to understand this problem. This is also another important problem. In board exam, they are asking the question like this also. Use the product. So first of all, find the product of these two matrices. Two matrices are given. You have to find the product of these two matrices and use this product, solve the system of equation. How to use, sir? How to solve it, sir? First of all, you find the product, then you will get an idea. First of all, as usual, find the product of two matrices. As usual, the matrix multiplication. So that is 1 minus 1, 2, 0, 2 minus 3, 3 minus 2, 4, and this is minus 2, 0, 1, 9, 2 minus 3, 6, 1 minus 2. Okay, right, use the product. So product means that is a row by column, multiplication of two matrices. Multiply the first row and first column. What is the answer? This is 1 into minus 2. Okay, this is minus 2. This is minus 9. Okay, totally minus 11. This is 2 into 6, 12. 12 minus 11, the answer is 1. You please try to understand. I am applying that product rule. Okay, row by column. Right? So multiply that. What is 1 into minus 2? Minus 1 into 9 plus 2 into 6. Totally 12 minus 11, that is 1. Now come to that first row, second column. What is the first row, second column multiplication? 1 into 0, 0. This is minus 2. This is plus 2. Finally, the answer is 0. This answer is 0. Okay. And come to the first row, third column. 1 into 1, 1. This is plus 3. This is minus 4. Actually, plus 1, plus 3, and minus 4. The answer is 0. Similarly, find the other row and column products. You will get 0 here, 1 here, 0 here, 0, 0, 1. That means you will get an identity. If you take a product for these two matrices, okay, simplify, you will get that identity matrix. I hope that you can easily understand the product of the matrix. If you want, you please send a message. I will work out writing all the necessary steps to find the matrix multiplication. How to multiply row by column. Okay. So therefore, this is matrix multiplication. I am getting that identity. Please note that if the two matrix multiplication is identity, please note that if two matrix multiplication is identity, I'm sorry, the two matrix multiplications are identity, A into A inverse is equal to identity, as well as A inverse into A is also identity. Okay. So if the matrix multiplication is identity means one is the inverse of the other. Okay. So therefore, if AB is equal to BA is equal to identity, okay, then what happened? If A is the inverse of B and B is the inverse of A. Are you okay? If AB is equal to BA is equal to identity, then A is the inverse of B and B is the inverse of A. Similarly, these two matrix multiplication is going to be identity means either this matrix inverse is this matrix inverse is this. Okay, no need to find out the inverse of anything because if you take this is A, this is your A inverse. If you take this is A, this is your A inverse because the multiplication is identity. Based on this result, we can conclude that if you take this is A, this is where A inverse. If you take this is A, this is where A inverse because the multiplication is identity. Okay, right. I'm going to take that this is my A. Why? I'm going to take that this is my Y because now look at that here 1, 0, 3 is their first column. In the system of equation also, the given system of equation also, what are the coefficients of x? 1. Here there is no x, coefficient is 0. Here 3, 1, 0, 3. Similarly, y coefficient minus 1, 2, minus 2. Here also minus 1, 2, minus 2. Z coefficient 2, minus 3, 4. Here also 2, minus 3, 4. So if you write this equation in matrix form, if you write the system of equation in matrix form Ax is equal to B, okay, the coefficient matrix is called as your A. You have to find out the inverse for the coefficient matrix A. So therefore, I am also going to take it as this matrix is A. Okay, so therefore, if I'm taking this matrix is A, then this is my A inverse. Okay, so therefore, I'm going to take it as this matrix as A. Why? This is the coefficients of, this is coincide with the coefficients of this system of equations. Okay, so therefore, my conclusion is, so here A into A inverse is equal to identity. So therefore, I'm going to take it as my A is equal to the first matrix, this matrix. Okay, so therefore, this is 1, 0, 3. This is -1, 2, -2. This is 2, -3, 4. Okay, into what is your A inverse? Your A inverse is the second matrix, this matrix. If you take this is A, this is A inverse. So therefore, this is your A inverse is 2, -2, 0, 1, 9, 2, -3, and 6, 1, -2. Okay, so this is your A inverse. Okay, now come to the problem. Problem means the solving a system of equations. This is a system of equation is given. Given system of equation is your x minus y plus 2z equal to 1, and 2y minus 3z equal to 1, and 3x minus 2y plus 4z equal to 2. This is given. Write it in the matrix form. What is the matrix form of this matrix? 1 minus 1, 2, 0, 2 minus 3, 3 minus 2, 4. Okay, and this is x, y, z unknown matrix, and the right hand side is 1, 1, 2. This is 1, 1, 2. Okay, right. Take it as this is A, this is X, this unknown matrix is X, this is A, this is X, the right hand side is B. So therefore, pre-multiplying A inverse both the sides and simplify, you will get it X is equal to A inverse into B. Okay, so now look at that. If this is your A, that means look at that, both the A's are same. Okay, if this is your A, here also your A, then what is the inverse of this A? This is the inverse. Directly apply that. No need to go for the determinant and adjoint of A, everything, because already we got our A inverse. If you do that, finding determinant of A, adjoint of A, everything, again you will get the same answer. No need to do that because the question is use the product is given. Using product, we can easily find the inverse of A and use this -2, 0, 1, 9, 2, -3. This is my A inverse, I am writing directly. This is my A inverse, I am writing directly the A inverse. 9, 2, -3, 6, 1, -2. Into B. What is my B? My B is this 1, 1, 2. Now just take a product, okay, and equate from this X, Y, Z. You will get the answer. Okay, so please try to understand. Now take a product. So this side is X is there. Here this is -2, 0, 1. This is 9, 2, -3. This is 6, 1, -2. This is 1, 1, 2. This is 2. Now take a product, matrix multiplication. Okay, -2, this is 0, this is +2. Okay, -2 +2, the answer is 0. And here this is 9, this is +2, that is 11, this is -6. Okay, so 11 - 6, the answer is 5. Okay, and this is 6, plus 1 7, and this is minus 4. So 7 minus 4, the answer is 3. Okay, now actually what is your x? Your x is x, y, z. So therefore these two matrices are equal. That means the corresponding elements are also equal. X is equal to 0, y is equal to 5, and z is equal to 3. This is the answer. How to verify your answer? How to verify your answer? You have to multiply these three values in the given equation. In all the three equations, if the your answer 0, 5, 3 satisfying all the three equation, your answer is correct, and this is the unique solution. Okay, right. Come to the next problem. Examine the consistency. Examine the consistency of the system of equations. Examine the consistency of the system of equations. The equations given as x plus 3y equal to 5, 2x plus 6y equal to 8. Okay, so first of all, write it in the matrix form. What is the matrix form? Write the coefficient. So that is 1, 2, 3, 6, and the unknowns x, y, and 5, 8, the B matrix. Okay, if you take this is where A, this is where X, this is equal to B means, so first of all, check that your A in determinant of A is not equal to 0. That means then only A inverse exists. Okay, the first case is if determinant of A not equal to 0 means A is non-singular. A is non-singular means where A inverse exists. A inverse exists means we'll go for X is equal to A inverse B. Okay, first of all, check that determinant of A is not equal to 0. Look at that, this is where A. A means, the determinant of A means this is 1 into 6, 6. This is also 2 into 3, 6. It is equal to 0. Okay. So therefore, this is 6 minus 6 is equal to 0. Right. Therefore, that is determinant of A is equal to 0. Determinant of A is equal to 0 means the matrix is singular. A is singular. Singular means we will go to the second case. What is the what about your second case? Okay, look at that. This is the first case. First case is A is non-singular. We will get A inverse. A inverse means we will get X is equal to A inverse B. We will get a unique solution. Look at the second case. A is singular means we have to verify that adjoint of A into B not equal to 0 means then the system is inconsistent. Adjoint of A into B equal to 0 means we may get equal to 0 means the system may be either consistent with infinitely many solution, okay, are inconsistent with no solution. Okay, so therefore we have to check that. The another case is second case is we have to check that adjoint of A into B, that is 0 or not. Based on that, we conclude that the solution infinitely many solution exists or the system of equation is inconsistent. Okay, we will check everything based on that adjoint of A into B. Right, now come to that. Find adjoint of A. What is my adjoint of A? I have already told that for adjoint of A for 2 cross 2 matrix, it is very simple. For 2 cross 2 means just interchange these two elements. Okay, and sign change of these two elements. So that is your adjoint of A. So therefore, this is 6, 1. This is minus 2, minus 3. Okay, interchanging of these two elements. 1, 6 interchanged to 6, 1. And this minus 2 and minus 3 can be written as minus 2 and 3 can be written as minus 2 minus 3. So now multiply adjoint of A into B. What is my adjoint of A into B? My adjoint of A is 6 minus 3 minus 2, 1. What is my B matrix? My B matrix is this 5, 8. Multiply that. Okay, so what is the matrix multiplication? So this is 6 5 are 30. This is minus 24. So 30 minus 24, that is plus 6. And similarly, this is minus 10 plus 8. So therefore, the answer is minus 2. This is not equal to 0 matrix. Okay, your adjoint of A into B not equal to 0 means the system is inconsistent. The system of equations is inconsistent. Okay, which implies the system has no solution. Are you okay? The system has no solution. Please try to understand. The system of equation inconsistent. Why adjoint of A into B is not equal to 0? Not equal to 0 means definitely it is inconsistent. No solution for that. Not only a single solution, even single solution not exist. Okay, unique solution also not exist. Many solution also not exist. So therefore, these are inconsistent. Now come to that another problem. Okay, so I hope that you can easily understand that the system of equations, solving system of equations in 2 cross 2 and 3 cross 3. I hope that you can easily understand, you can easily work out the problems, you can find the solution of the problems. Okay, right, we'll discuss one more problem. And in previous problem, in these problems, equations given. In every problem, equations given. Okay, in the next problem, we have to form the equation and then we have to solve the equation. Okay, so we have to form the equation and we have to solve the equation. Right, so how to form the equation? Look at the next problem. That is an exercise. This is an exercise 4.6 problem. The last problem, I think, that is a 16th problem. Okay, the cost of 4 kilogram onion. I just write the problem. The cost of, those who are having books, you please refer the book. The cost of 4 kg of onion, 3 kg of wheat, and 2 kg of rice is rupees 60. The cost of 2 kg of onion, 4 kg of wheat, and 6 kg of rice is rupees 90. Okay, the cost of 6 kg of onion, the cost of 6 kg of onion, 2 kg of wheat, and 3 kg rice is rupees 70. Okay. So find the cost of each item per kg by matrix method. Find the cost of each item per kg cost of each item per kilogram by matrix method. Matrix method means this determinant method. That is usually called as matrix method because of we are finding the inverse for the matrix. So therefore, this is called as a matrix method. Okay. So look at that here. The three items they are discussing: the cost of onion, cost of wheat, cost of rice. Okay. So I'm going to take it as let the cost of onion, wheat, and rice the cost of onion, wheat, and rice of 1 kilogram. I'm going to take it as 1 kilogram per kilogram. Okay, B rupees X rupees Y rupees Z respectively. Okay, I'm going to take it as the onion cost is X and I'm going to take it as wheat. That means 1 kilogram cost is Y and 1 kilogram of rice cost is Z and 1 kilogram of onion cost is X. I'm going to take it as 1 kilogram of onion is X, 1 kilogram of wheat is Y, 1 kilogram of rice is Z rupees. Okay, now form the equation. So here, how much kilogram is given? 4 kilogram of onion. 1 kilogram is X rupees. 4 kilogram is 4X rupees. So therefore, 4X. Here, 1 kilogram is Y. What about 3 kilogram of wheat? So that is 3Y. The cost is 3Y. Okay, here 1 kilogram is Z. 2 kilogram is 2 into Z. So therefore, this is 2Z. Okay, this is the rice cost, this is the wheat cost, this is the onion cost. Totally, it is rupees 60. You please note that your first equation is 4x plus 3y plus 2z equal to 60. Similarly, second equation, what is my second equation? The cost of 2 kilogram onion. So therefore, 2x plus 4 kilogram of wheat plus 6 kilogram of rice equal to 90. Okay, the third equation is the cost of 6 kilogram of onion, okay, plus 2 kilogram of wheat plus 3 kilogram of rice is equal to 70. Okay, so now we have to solve these equations. Okay, solve these equations by matrix method as usual by take it as coefficient matrix is A, unknown matrix is B, and the right hand side matrix is take it as unknown matrix is X, the right hand side matrix is B. Okay, please take that. So what is your A matrix? I'm going to write that coefficients. Okay, what are the coefficients of X? So that is 4, 2, 6. And coefficient of Y? That is 3, 4, 2. Okay, coefficient of Z? 2, 6, 3. Okay, and unknowns. Unknown matrix is X, Y, Z. And Z. On the right hand side is 60. This is 90. This is 70. Okay, I'm writing everything from these three equations. Okay, I'm writing the coefficient of X in the first column, coefficient of Y in the second column, coefficient of Z in the third column, and right answer 60, 90, 70. Okay, now take it as this is your A matrix, this is your X matrix, this is your B matrix, and pre-multiplying both the sides by A inverse, you will get X is equal to A inverse into B. First of all, find your A inverse. What is your A inverse? Your A inverse formula is A inverse is equal to 1 by determinant of A adjoint of A. Okay, find determinant of A. How to find out the determinant of A? Your determinant of A is 4 into, this is plus minus plus. I'm expanding the determinant by the first row. So 4 into this is 12 minus 12. So this is also 4 3s are 12. This is also 6 into 2, 12. 12 minus 12, 0. This is minus 3 into, this is minus 3 into, this is 2 3s are 6. Minus this is 6 into 6, 36. Plus this is 2 into, this is 2 into 2, 4. Minus 6 4s are 24. So therefore this is 12 minus 12, 0. This is minus 30. Minus into minus plus 30 into 3, 90. Okay, and this is minus 20. Minus 20 into 2, minus 40. So therefore the answer is 50. This is not equal to 0. Not equal to 0 means A is non-singular. Non-singular means A inverse exists. Okay, so write that A is non-singular. Right? A is non-singular means A inverse exists. Find the A inverse. Find the adjoint of A. How to find out the adjoint of A? So we can find the adjoint of A in one matrix. I will write it in the next slide. A is non-singular. It is very simple to show that. Come to that adjoint of A. Right. First of all, you take it as your A. What is your A? Your A is 4 2 6 and 3 4 2 2 6 3. Am I correct? 4 2 6 3 4 2 2 6 3. Okay. So now write that minor of this element. What is the minor of this element 4? So minor of this element is, this is 4 6 2 3. This is a minor of this first element. Okay, write the minor of this element, that is 2 6 6 3. I am just writing the minus. Okay, what is the minor of this element? Minor of this element is 2 4 6 2. Okay, you please try to understand what I'm doing. I'm just writing the minus. Okay, right. Write the minor of this element. What about the minor of this element? Leave this row, leave this column. So therefore, this is 3 2 2 3. Okay, right. Minor of this element. Minor of this element is leave this row, leave this column. 4 2 6 3. Minor of this element is 4 2, determinant of 4 2 and 6 3. And minor of this element is 4 3 6 2. Minor of this element is 4 3 6 2. This element means leave this column, leave this row, remaining 4 3 6 2. Now come to that minor of this element 6. That means leave this column, leave this row, 3 2 4 6. Okay, and minor of this element is minor of this element. Leave this column, leave this row, 4 2 2 6. Okay, and minor of this element is 4 3 2 4. Okay, right. So take a transpose and look at that. These are the minus. How to make it as a cofactors? Just multiply by plus, minus, plus, minus, plus, minus, plus, minus, plus. You multiply the cofactors by plus, multiply the minus by plus, minus, plus, minus, plus. It will become cofactors for 3 cross 3 matrix. And finally take a transpose. Okay, so now what is the answer? Simplify that. So here this is 4 3s are 12 minus 12. So therefore this is 0. And come to that, this is 2 into 3 is 6 minus 36. Okay, so therefore this is minus half 6 minus 36. This is plus half 4 minus 24. Okay, this is minus half 9 minus 4. This is plus half 12 minus 12. And this is minus half 8 minus 18. And this is plus half 3 6 are 18 minus 8. And this is minus half 24 minus 4. And this is plus half 16 minus 6. So therefore this is equal to, this is 0. This is actually minus 36. 6 minus 36 is minus 30, minus into minus plus 30. Okay, and here minus 24 into plus, minus 4 minus 24 minus 20 into plus, that is minus 20. Okay, and here it is plus 5 multiplied by minus, minus 5. And here it is 0. Here it is minus 10 multiplied by minus, that is plus 10. And here 18 minus 8. 18 minus 8 is 10 multiplied by plus. 24 minus 4 is 20. 20 minus multiplied by minus, minus 20. And here 16 minus 6 is 10. Take a transpose, that is very important. Okay, so this is your adjoint of A. Look at that. Instead of finding the adjoint of A, minus cofactors, everything, I am writing that adjoint of A in one matrix. You can write this also in your exam. So write the adjoint of A directly. That means writing minus cofactors, everything in one matrix, and take a transpose. Simplify this and take a transpose. That is your adjoint of A. Okay. So therefore, your adjoint of A equal to, take a transpose. Transpose means 0, 30, minus 20, minus 5, 0, 10. Minus 5, 0, 10, 10 minus 20, 10. Okay, right. Now come to that. Your X is equal to A inverse into B. What is my A inverse? My A inverse is 1 by determinant of A. What is my determinant of A? My determinant of A is 50. 1 by 50. And adjoint of A. What is my adjoint of A? 0, minus 5, 10. And here 30, 0, minus 20. And minus 20, 10, 10. Okay, into B. What is our B? Look at that B. So B means right answer, 60, 90, 70. Now multiply and simplify. 1 by 50. So this is 0. This is minus 5 into 90, minus 450. Okay, this is 10 into 70, 700. So therefore, this is 700. This is 10 into 70, 700 minus 450. Okay, so therefore, this is my plus 250. First one is 0. Right, now this is 3 into 60. 30 into 60. Okay, so therefore, this is 1800. And this is 0. This is my 1000, so minus This is 1800. This is minus 20 into 70. That is 1400. Okay, 1800 minus 1400. What is the answer? It is 400. Similarly, multiply this. Okay, so therefore here also simplify that. Here also you will get 400. So divide by 50. So therefore the left hand side is we are having x, y, z. Right hand side we are having, that means divide 250 divided by 50. What is the answer? It is 5. And 400 by 50. What is the answer? It is 8. Okay, and 400 divided by 50. What is the answer? It is 8. Okay, which implies your x is equal to 5, y is equal to 8, z is equal to 8. You simplify this, you will get a 400 is the answer. Minus 20 into 600. Okay, so that is 1200. This is 900. Okay, so this is 700. Okay, so 900 plus 700. So that is 1600. Okay, 1600 minus 1200. That is 400. You will get the answer. This is a solution. You have to verify this solution using these values in your given problem. Okay, here, right? Apply in this equation. If the solution satisfying this equation, then only your answer is correct. That means your x is price of onion, y is price of beet, z is price of rice. Okay. So one more problem, that is a simple problem. Solve the system of equation. Five x plus 2y equal to 4. 7x plus 3y equal to 5. Solve this. 5x plus 2y is equal to 4. 7x plus 3y is equal to 5. Solve the system of equation. Try to find the answer. Write it in matrix form. Write this is in matrix form and write x is equal to A inverse B. Find A inverse, where A inverse is 1 by determinant of A adjoint of A. What is the determinant of A? What is the adjoint of A? What are the values of x and y? Write it in a matrix form. What is the answer for determinant of A? Where determinant of A is equal to 1. Your adjoint of A is 3 minus 2 minus 7, 5. Write A inverse and take a product A inverse into B. What is the answer? You are getting x and y. You're getting determinant of A is equal to 1. You please check that. The determinant of A is equal to 1. Your adjoint of A equal to, this is 3, 5, this is -2, -7. Okay. And multiply that, what you are getting, your x is equal to 2, y is equal to -1, I think. X is equal to 2, y is equal to -3. Okay, right. The homework is exercise 4.6. Okay, you please try to complete that 4.6. All the problems in that 4.6. Those who are not getting the answer, you please try to get the answer. Determinant of A is equal to 1. Try to find out the adjoint of A. Try to complete the problem. X is equal to 2 and y is equal to -3. Okay, thank you all. You please try to complete the exercise problem. Okay. And tomorrow we will discuss some miscellaneous problems. Within 1 or 2 classes, we will finish this chapter and we will move to the next chapter, continuity and differentiability. Okay. Thank you all. Thank you so much. Thank you.